Hello everyone, this is Saha. Hope guys you are well. Today I have come with a new topic, buck converter. Please subscribe my channel and stay with me. Before designing, must we have a small idea about the buck converter? Let's take an idea. Suppose you have a 200 volt power source and your device have a device that will be conduct with 20 volt power source. But if the device will get 200 volt, the device get busted. So we reduce the voltage to 20 volt. So suppose we design a buck converter by PSIM power simulation and how we saw that how reduce the voltage 200 volt to 20 volt. Let's start. Let's go with PSIM. And also I have designed two AC, two DC, and DC to DC buck converter design. Let's start. Let's start our design. We know how can we collect from the component, and if we don't know, then we see the previous video in my playlist. So we start our design. Firstly, we need DC voltage source and need a diode. Then we collect MOSFET. In the we see the down. We see MOSFET. This is our MOSFET, and we need a switch to control the MOSFET. And we connect as pulse square wave. There's why we connect square wave. We know from the our theory course, so we cannot details about it from this section. So we need inductor and then capacitor. Then lastly we need resistor. Complete wiring. At last we need voltage measurement in source side and also voltage measurement in resistor side. We connect emitter to input and measure output voltage, and we connect a ground. After complete the design, we see a simulation control clock we know, and the input voltage is 136 volt and output voltage is 85. That reduces our voltage, and this value randomly chose and 100 kilohertz and 0.5. We taken square of value, and this how to value choose we know from our theory course, but in this site we cannot prove our this value. How can we find out the value? We should only find out how can design a circuit in our simulation, and with this is we show our output voltage 85 and input voltage 136. That's our assumption was right, and reduce the voltage. This is our buck converter, and this is our MOSFET, and this is our getting switch. We control the MOSFET, and this is basically DC to DC buck converter. And next we design AC to DC buck converter. Next, so in another design, if I forget about the graph, we see the graph. Our DC voltage 136 volt DC voltage and output voltage was 85 85 voltage, and this is our Also a DC graph we find some ripple in this. Why we can see ripple we will discuss later. Next we start another AC to DC converter. In this section we design a AC to DC buck converter. We saw a rectifier use because we know AC source we reduce AC to DC, so we need a rectifier. So we this use a rectifier to DC voltage. Input voltage was 136 volt and 50 hertz. So we know AC frequency in Bangladesh 50 hertz, so we use 50 hertz. And input side we use a rectifier. Sorry, we use a inductor and capacitor we use to reduce the input ripple, and rectifier we use because we convert the AC to DC. And then we use 100 kilohertz, and this part we also know from the previous part. DC to DC converter we same portion we use, and the output voltage we find out 80 volt. This is we show the reduce the voltage, and we see the graph. We output, and this is our output voltage. And if we see the input voltage, this is our input DC voltage, and this is our output voltage, and close to the 80 volt. Is it 80 volt? So and then we find out some ripple, we reduce the ripple from further analysis. But in this portion we see that this is buck converter, so we cannot deeply go. And in this block we use also another source. This is called getting block. We also use a getting block. Why we can use a getting block? I will reply. Firstly we connect a getting block. Previously in this section we 100 kilohertz, so we put 100 kilohertz. But previously we in this value we put set the value is 0.5%. That's mean uh, if we design a sine wave, this is our 360 degree. We know this is our 360 degree. Previously we in this section we set 0.5. That's mean half portion of this wave. That's mean 180 degree. So we also reply that, also said that the 0.5 is the one of the degree and the radian conversion. So in this section we input voltage is 0 to 180 degree. And previously we getting block put in this value 0.5. This is also same here. One part is radian and also another part is the and degree. So we put the degree value, and after we see the simulation we find out the same simulation. And question given is degree value, so we use this getting block. And after we find out another getting block, we find out we use this switch also, and the square wave also. Thank you everyone, please subscribe my channel. And this is the part. Thank you everyone.